Here is our ISC for the subject computer network. Now we are going to present presentation on IP addressing. Our group members are Anushka Dhotre, Akanksha Sawant and Shruti Suryanshi, guided by Mr. Krunal Pawar sir. See the introduction. An Internet Protocol address is a numerical label assigned to each device participating in computer network that uses the Internet Protocol for communication. An IP address serves two principal functions that are host or network interference identification and location addressing. The rapid explosion of Internet and existence of high-speed wireless and broadband networks have contributed towards depletion of IPv4. The IPv4 protocol created more than 3 decades ago with approximately an address space of 4 billion cannot cater to the needs of modern Internet. The IANA means Internet Assigned Numbers Authority allocated last chunk of IPv4 addresses on Feb 3, 2011 to the regional internet registers announcing end of IPv4 address. The address deflation has posed a serious problem on the growth of internet networks. The short-term solutions like PPP or DHCP, CIDR, and NAT do not seem to the help considering the number of devices that are getting connected to the internet daily. Also, as the protocol was developed a long time back, the features related to mobility, security, and QoS are handled by additional protocols which cannot be integrated within the protocol. Let's move to the concept of IP addresses. As we know that an Internet Protocol addresses is a numerical label assigned to each device. There are 5 classes of IP addresses. Class A addresses, Class B addresses, Class C addresses, Class D addresses, and last class. Let's see the first class, that is Class A addresses. The first bit of a first octet is always set to 0, thus the first octet ranges from 1 to 127. Class A IP address format is given here. Now the Class B addresses. An IP address which belongs to the Class B has first 2 bits in the first octet set to 10, and it ranges from 128 to 191, and the IP address format is given here. Now the Class C addresses. The first octet of Class C IP addresses has its first 3 bits set to 110. It ranges from 192 to 223, and the IP address format is given here. Now the Class D addresses. Very first 4 bits of the first octet in Class D IP addresses are set to 1110, and it ranges from 224 to 241. Class D is reserved from multicasting. In multicasting, data is not destined for a particular host. That is why there is no need to extract host addresses from IP addresses, and Class D does not have any subnet mask. Now last, the Class E addresses. IP addresses in the class ranges from 240 to 255. Like Class D, this is the code is not occupied with subnet mask.
Hello everyone, myself Akanksha Sunil Sawant. Now we are going to discuss about the functions of IP addresses. The IP address serves two main functions. First is host or network interface identification, and second location addressing. In host or network interface identification, the IP address identifies the host, or more specifically we can say its network interface. In location addressing, it provides the location of the host in the network and thus the capability of establishing a path to that host. As we know, an IP address allows information to be sent and received by the correct parties, which means they can also be used to track down a physical location. Now, IP versions. There are two versions of IP in use today, that is IPv4 and IPv6. During the development of the first version of the Internet Protocol in the 70s of the previous century, the initial experimental versions 1, 2, 3 were not standardized. The first working version that was widely deployed was assigned version number 4. A separate protocol based on reliable connection was deployed and assigned version 5. IP version 7 was chosen in 1988 by R. Uleman in the next IP version because he incorrectly assumed that version 6 was in use of ST2. However, ST2 had reused the version 5 of the original ST protocol. When it became apparent in the early 90s of the previous century that IPv4 could not sustain routing in growing internet, several new protocols were proposed. The Internet Protocol that finally emerged was assigned version number 6, being the lowest free number greater than 4. The PIP protocol, which means a private internet protocol, and TUBA protocol, which means TCP/IP UDP with bigger addresses protocol, used versions 8 and 9, following version for TPIX. Only IPv4 and IPv6 packets are seen on the internet today, having IP versions number 4 and 6 respectively, which we are going to see further in details.
Hello, my name is Anushka Shokdhotre and my roll number is 1903096. IPv4. It is 32-bit numbers represented in 4 decimal number where each decimal number is of 8 bit is separated by a dot. An IPv4 address is that uniquely and universally defines the connection of a device to the internet. Two devices on internet can never have the same address at the same time. IP address consists of two components, the network ID and host ID. Network ID, it is the number assigned to network in the internet. Host ID, it represents the ID assigned to host in the network. IPv4, in that there are 5 classes of IP addresses: Class A, Class B, Class C, Class D, and Class E. Class A, the first byte is network ID and last 3 bytes are for the host ID. The first bit is 0. Range of the network number is 0 to 127. Number of possible networks are 128. Class A is used for the large network. Class B, the first 2 bytes are the network ID while last 2 bytes are for the host ID. The first 2 bits are 10. Range of the network number is 128 to 191. The number of possible networks are 16,384. The Class B is used for medium size network. Class C, the first 3 bytes are the network ID and last 1 byte is for the host ID. First 3 bits are 110. Range of the network number is 192 to 223. Number of possible networks are 2,97,152. Class C is used for the local area network LAN. Class D, An IP address which belongs to class D has the first octet and its 4 bits set 1110. Range of the network number is 224 to 239. It is used for the multicasting. Class E. It is reserved for experimental and for future testing purpose. Range of network number is 240 to 255, where the class E. These are the some classes of the IP addresses. IPv6. IPv6 will make use of 128 bits IP addresses. An IP addresses is represented as 8 groups of 4 hexadecimal digits, each group representing 16 bits. The group are separated by colons. The length of IPv6 is 4 times the length address of IPv4. Type of IPv6 are unicast addresses, multicast addresses, anycast addresses. In that, first one is unicast addresses. It identifies a unique node on network and usually refers to a single sender or single receiver. Multicast addresses. It represents a group of IP devices and can only be used as the destination of a datagram. Anycast addresses. It is assigned to a set of interfaces that typically belongs to different nodes. These are the IP addresses of versions.
Hello everyone, myself Akanksha. Now we are going to discuss the difference between IPv4 and IPv6. As we earlier discussed about the IPv4 and v6 in details. First point of our distinction is based on the length of the IPv4 and IPv6. IPv4 has 32-bit address length, whereas the IPv6 has 120-bit address length. IPv4 supports manual or DHCP address configuration. It supports auto and renumbering address configuration. In IPv4, the assigning of IP addresses is done manually and by using DHCP address configuration. DHCP means Dynamical Host Configuration Protocol. In this, DHCP server is used to assign an IP address. Where in IPv6 it is assigned automatically and by using renumbering address configuration. In IPv4, end-to-end connection integrity is unachievable. In IPv6, end-to-end connection integrity is achievable. Integrity means completion of data. In IPv4, there may be chance of loss of data, whereas IPv6 there is no such a case, that which means that IPv6 is more secure than the IPv4. In IPv4, checksum field is available. In IPv6, checksum field is not available. Checksum means it nothing but the value which represents the number of bits in a segment, which is generally used to check whether error is occurred or not during the transmission of the data. Security features is dependent on the application. IPsec is inbuilt security feature in IPv6 protocol. Security as IPv4 is not much secure. It is it To fulfill the security needs, we need applications to ensure its security, whereas in IPv4, IP6 is inbuilt security feature. Address representation of V4 is in decimal and address representation of IPv6 is in hexadecimal, as we mentioned in the previous slide. Fragmentation performed by sender and forwarding routers. In IPv6, fragmentation performed only by sender. Fragmentation means breaking down the larger packets into the small pieces so that it can easily pass through the data links while transmission of the data. Uh, this is done on the both the side sender and at the router side, whereas in IPv4 fragmentation is performed only at the sender side. There are more such points to distinguish IPv4 and IPv6. We have covered only few points here. Now, the conclusion. From this presentation, we have concluded the role of IP address, how it helps to handle the connection between devices that send and receive information across a network. Computers use IP addresses to communicate with each other, both over the internet as well as on the other networks. Also, we understood the IP versions, that is IPv4 and IPv6, along with their addresses, and also we discussed and understand the difference between them. Thank you.